Hi everyone. What we're doing today is products of acid reactions. Our syllabus outcome is predict the products of acid reactions and write balanced equations to represent acids and bases, acids and carbonates, acids and metals. So, revision from last lesson. Make sure you've done the revision questions beforehand, but here are the answers. Indicators are intensely colored compounds that change color depending on pH. Arrhenius acids dissociate to form H+, and bases dissociate to form OH-. Bronsted-Lowry acids donate a proton, and Bronsted-Lowry bases accept a proton. Common acids include hydrochloric acid, so HCl, sulfuric acid, which is H2SO4, and acetic acid, which is CH3COOH. Okay, so we did do this in module 3. Okay, we did acid and base reactions, acid and carbonate, acid and metal. So remember, an acid and a base, when mixed, gives a salt plus water. Acid and carbonate give a salt plus water plus carbon dioxide. And acid plus a metal gives a salt plus hydrogen gas. Okay, so the acid reactions that we covered in the prelim course are the same ones that we use in the HSC course, though we will be expected to do a little bit more with them, such as balancing, mole calculations, limiting reagents, and linking to Avogadro's number and the gas law. So there's some of the harder things that we have to do with these. Quite often it'll be, mix this with that. What are the products? How many moles of the products? How many moles of gas have been liberated, or something like that? Or we'll have this amount of acid, this amount of base have been mixed together, and one of them will be a limiting reagent. So calculations involving acids and bases. When calculating things with these reactions, we follow a general procedure. We determine the information the question gives us and what it's asking us to find. Okay, so if you're in any of my physics class, this is GRESS, very similar. So we find what's given and what's required. We use the general reactions and the Arrhenius or Bronsted-Lowry definitions of acids to predict the products. Third, we write a balanced equation for the reaction, and then we try to figure out how to calculate what we need with the information that we're given. So it usually involves calculating some moles, comparing them through their molar ratio, and then calculating whatever it is we need. Okay, and then lastly, we attempt to find the answer. Okay, if we've done all of that right, we should get a large way towards the answer. So let's have a go at some. So these are the types of calculations that we have to do. 2.4 grams of magnesium metal is reacted with excess nitric acid. What is the mass of hydrogen liberated during the reaction? Okay, so we first go through and we find out what we're given. Okay, what we're given, the useful things to look for are numbers, so quantities, compounds, units, and meaningful phrases. Okay, again, this is a physics one, but it's the one that comes to the top of my head every time I think of meaningful phrases, which is something like at rest means zero velocity. They're the meaningful phrases that I'm looking for. In chemistry, I just thought of one which is in excess. Okay, whenever we're talking about something in excess, it means we've got enough there to react. We don't need to calculate anything. It means the other thing's the limiting reagent. So let's have a look at what we've got in this question. So 2.4 grams of magnesium metal. We've got 2.4 grams. That's some information. Write that down. Mass equals 2.4 grams. Even better, mass magnesium equals 2.4 grams. Okay. It's magnesium metal. Okay, so that tells us that it's magnesium without a charge, and it's going to react with excess nitric acid. So suddenly we know, we've also figured out that it's got a metal reacting with acid. So we can use a general equation for that. And it's in excess. So the magnesium metal is going to be our limiting reagent. So that's the only calculation that we have to do. We don't have to do any calculations for nitric acid. So mass of magnesium is 2.4 grams. Now, what are we required to find? Usually includes statements like what is, find the, calculate, evaluate. Okay, they're the common ones that we find. So what is this one? What is the mass of hydrogen liberated during the reaction? Okay, so it's mass of hydrogen. So we're actually trying to find the mass of the hydrogen liberated. So mass of H2. That's our question mark. First step in these questions is always to write the reaction equation and then balance it. So we know we had a metal in the form of magnesium metal. We had an acid in the form of nitric acid. So that's what we're going to react. What do we form? Well, we form a salt. Now what we're going to get is we're going to get magnesium nitrate. So we take the anion from the acid and the metal, clump them together. We get magnesium nitrate, and finally we're going to have H2, which is gas. Now if we look at that straight off the bat, it's not balanced. We have one magnesium on both sides, but we have one hydrogen on the left, two on the right. So we're going to have to slap a 2 right in front of that nitric acid. So now the hydrogens are balanced. We now have 2 nitrates. We need another nitrate on the other side. Sorry, that 2 shouldn't be there in front of the that H2. So just ignore that one. Okay, so we have 2 HNO3, magnesium nitrate, and hydrogen gas. So that's now balanced. So again, ignore that 2 because I can't review my notes. Now we need to figure out how to get from where we are to what we want. Our mass of magnesium is 2.4 grams. We want to get our mass of hydrogen. So how do we get there? Well, firstly, we find the number of moles of magnesium. Once we've got number of moles, we can compare across the reaction. So we can compare it through molar ratios to the number of moles of hydrogen. And then we can convert that back to mass. Now, remember, we can only compare values through moles. So we can't compare the mass of magnesium to the mass of hydrogen without going through moles first. So let's do it. Moles equals mass over molar mass. 2.4 over 24.3, which should give 0.0988 moles. Okay, that's of magnesium. Now we compare it to the hydrogen. So I've got there that they're equal. For some reason, that 2 still persists because copy and paste lets me down every time. Okay, so number of moles of hydrogen is equal to the number of moles of magnesium. So number of moles of hydrogen, 0.0988 moles. And so we can then calculate the mass of hydrogen just by multiplying the number of moles by the molecular mass. So 0.0988 times 2.016, which is 0.1992 grams. Okay, so these are the kinds of questions that we will be expecting. Now, example 2, 5 grams of solid sodium bicarbonate is reacted with an excess of acetic acid. What volume of gas is liberated at standard temperature and pressure? So let's have a look at what we've got. 5 grams of solid sodium bicarbonate is reacted with an excess of acetic acid. Now, you guys should look at that and go, oh, bicarbon vinegar. That's exactly what it is. It's going to liberate carbon dioxide gas. Let's get to that in a sec. We also want to have a look at what's required. So we want to find out, special phrases. It's reacted with an excess of acetic acid, which means that we only need to calculate the number of moles of sodium bicarbonate. We've put in enough acetic acid that all of the bicarbonate will react. What we're looking for the volume of gas. That's standard temperature and pressure. Okay, now we've got a volume of gas. Now the standard temperature and pressure, that's an important phrase that will come into play later on. So we have mass of sodium hydrogen carbonate, 5 grams. What gas is produced? Carbon dioxide, I already gave you that result. What type of reaction is it? Well, we have a carbonate in there. I mean, it is bicarbonate, just means it has an extra hydrogen, but it's still a carbonate. It still reacts with acid the same way. So we want to find the volume of carbon dioxide gas at the end. We'll balance the equation, then we'll figure out the path. So we have sodium hydrogen carbonate, acetic acid. When they mix, we get sodium acetate, water, carbon dioxide. So remember, that's our general reaction, a salt plus water plus carbon dioxide. Now, that's where we are, that's where we want to go. So how do we get from mass of sodium hydrogen carbonate to volume of CO2? Well, CO2 volume can be calculated from moles because it's standard temperature and pressure. And moles of sodium hydrogen carbonate can be calculated with the mass. And because moles are directly comparable, we can go that way. So we can go figure out the number of moles of, so that should say sodium hydrogen carbonate. We can then compare to the CO2, find the number of moles of CO2. From that, we can find the volume. So sodium hydrogen carbonate plus acetic acid gives us sodium acetate plus water plus carbon dioxide. Number of moles of sodium hydrogen carbonate is mass over molar mass. So it's 5 over mass of sodium, which is 22.99, plus the mass of hydrogen, plus the mass of carbon, plus the mass of 3 oxygens. So number of moles is 0.0595. Number of moles of CO2 is equal to the number of moles of sodium hydrogen carbonate, because we can see there in the reaction it's 1:1. So therefore the number of moles of carbon dioxide is the same, 0.0595 moles. Now this is where our standard temperature and pressure, so that important phrase, that's where that comes in. So volume of standard temperature and pressure, it's on our formula sheet. If you go to your formula sheet, you should be able to find it. Standard temperature and pressure is usually 25 degrees, and that's 24.79 liters per mole of gas at 25 degrees Celsius and 100 kilopascals. So we multiply that by the number of moles that we have, so 0.0595, and we get 1.475 liters. Okay. Example 3. I'd like you guys to have a go at doing this first, and then we'll go through it as a group. So pause the video now, have a go at that, see how far you can get, and then come back and we'll do the answer. Okay, let's highlight what we've got. 0.1 moles per liter. So that's a quantity. It is concentration, and it's concentration of sulfuric acid. And that would react completely with 23 mils of 0.2 molar sodium hydroxide. Now what's it asking for? It's asking us what volume. And so we're going to need to figure that out. Now, and react completely. So we need to add just the right amount. So we're given concentration of sulfuric acid, volume of sodium hydroxide, concentration of sodium hydroxide, and so we need to find out the volume of H2SO4. Balance the equation, then we'll figure it out. So H2SO4 plus sodium hydroxide, it's an acid and a base, so you should create a salt plus water. And that's what we got there. Now we can see on the left side there's 2 sodiums, on the left side there's 1 sodium, on the right side there's 2 sodiums, so we're going to have to balance that out. We can see that one side has 3 hydrogens, the other side has 2. One side has, both of them have 5 oxygens, so that's okay. But we need to work on those sodiums and those hydrogens. So what can we do? Firstly, we can put a 2 in front of the NaOH. That gives us 2 sodiums, 2 hydroxides. We can also put a 2 in front of the H2O, because now we have 4 hydrogens, and so we're going to need 4 hydrogens from the water molecules. And if we count up the oxygens, there's 6 oxygens on both sides, 2 sodiums on both sides, so we're balanced. So what we have, volume of H2SO4 is our question mark, that's what we need to find. We have a concentration of sodium hydroxide, a volume of sodium hydroxide, and a concentration of sulfuric acid. So what do? We can use these two to create the number of moles of sodium hydroxide. We can use that using our stoichiometric ratios. We can then find the number of moles of sulfuric acid. So it'll be half the number of our moles of sodium hydroxide. And then from that, we can combine those two, so moles and concentration, to find our volume. So let's do that. So number of moles of sodium hydroxide is 0.0046 moles. Now we know the reaction rate is 2 to 1. So the number of moles of sulfuric acid should be half the number of moles of sodium hydroxide. Because again, we have 2 and 1. And so we should get 0.0023 moles of sulfuric acid. We can then calculate the volume of sulfuric acid using number of moles and concentration. So moles over concentration gives us volume. So 0.0023 divided by 0.1 equals 0.023 liters, or 23 milliliters of sulfuric acid. Okay, so they're the examples. Here's a summary. Acid and base gives us salt plus water. Acid and carbonate gives us salt, water, and carbon dioxide. Acid and metal gives us salt plus hydrogen gas. Answering these questions involves predicting the products, writing the balanced equation, calculating the moles, and comparing moles through molar ratio. And that is all for today. Thank you very much.